Let's have a look at question 7 now. So, if 9 students are chosen at random, the probability that their average time for the test completion is more than 150 minutes is going to be the following: true or false. Now, this is the same question related to our statistics test, but the keyword now is going to be average time. So we're going to draw the distribution that we had here once again to understand what's happening, because there's going to be a slight difference. So we still have the normal distribution with the average time for writing the test of 132 minutes and the standard deviation of 12 minutes. So let's write it like that: 132, standard deviation of 12. But notice that now what we're interested in is 150 minutes for an average time for 9 students. So from the entire population, we are selecting a sample of 9 observations. So we want to know by how many standard errors this sample mean is going to deviate from the population mean. Now, the reason I stress the word standard error, because the standard error is different from the standard deviation. They're not the same. The standard deviation happens to be for the population, but the standard error happens to be for the sample that we are selecting. So the standard error for the sample size that we're selecting of 9 observations is gonna equal to the standard deviation of the population divided by the square root of n. So in this case, the standard error that we're taking into account is gonna be 12 divided by square root of 9, which is 12 divided by 3, and that's equal to 4. So that is the standard error. We want to know by how many standard errors the average mean is going to differ from the population mean, and that's how we're going to standardize our Z statistic. Now let's do it here below. So before we had the Z value, the Z statistic, which was the difference between x and mu divided by the standard deviation. What we're working with now is the average mean of a sample of 9 observations, and we're dividing by the standard error. So we're dividing by the standard error, meaning that the Z value corresponding to this test is going to equal to the difference between 150, because we want to know the probability for having a completion time more than 150 minutes. We're going to draw this on a graph in a second. Let's just do the math real quick. So by how much does 150 deviate from the population mean of 132 minutes in terms of standard errors, which is 4. So 12, we have here 22 divided by 4, that's equal to 2.5. So 2.5 is going to be our Z value. Now if we draw the standard normal distribution for this test on the Z distribution, standard normal distribution is our Z distribution, and we know that we're having a Z value of 2.5. So we have a Z value of 2.5. We're looking for 2.5. We're looking for this proportion over here, for this probability over here. Now before going further, let me draw something else, which is the middle of the Z distribution. The middle of the Z distribution is going to be 0, because 0 happens to be the probability that the sample so the sample mean that we're finding equals to the population mean. Why is this 0? Because the probability of finding a sample mean, a sample average, out of an entire population being exactly equal to the population average is 0. Because we have so many possible outcomes, infinitely possible outcomes, that specific probability of hitting exactly the population mean is equal to 0. That's why the Z distribution has the mean of 0. Now, the Z distribution is also known to be symmetrical, meaning that every value that we have on the right, we also have on the left. Meaning we have a 2.5 Z statistic, we also have a minus 2.5 Z statistic with the same probability. Now, because the Z distribution gives the values, the probabilities to the left of the value, so if we look in the table, if we look at the probability that Z is greater than 2.5, we're not going to find it. It's not given. It's given only the probability that Z is less than 2.5. But the probability that Z is less than 2.5 is this entire area over here. So what we can do, we can just look at the probability that Z is less than minus 2.5. Probability that the Z is less than minus 2.5, which is going to be just this small tail that we need. And this small tail also corresponds to the tail over here, is the same probability, the same proportion. And the proportion, the probability that z is less than minus 2.5 is equal to 0.0062. So very small probability. And if we have a look at the answer key, the answer is 0.0668, which is not true. So the answer is false, and we are done.